Hello, welcome back to our channel. This week we are going to be tackling another of your requests, January 2022 question 9. So without further ado, let's jump right into it. Okay, so question 9 deals with geometry and trigonometry. So we are given this complicated looking diagram here, or seemingly complicated I should say, where we have a circle and several triangles inside it, and we are asked to find three angles, X, Y, and Z. So I'm just going to scroll down so you can kind of get a sense of the first of these. So part A has three parts. Each of those parts requires you to find X, Y, and Z, right? And they're also asking you to give a reason for why, for whatever answer you get. So let's start with the first part. I've written them down on the top here. We are trying to find X, Y, and Z and give a reason for it. Okay, so let's start with X. As you can see at the bottom here, we have three different angles that all have X in them. So what can we do here? So if you look at this line right here is the diameter of the circle. The diameter of a circle forms a right angle with a tangent. This line right here is a tangent. So what that means is that this angle right here between the diameter of the circle and this tangent is a right angle triangle. Now if you look at this right angle here, which we know is 90 degrees, right? We know in total this must be equal to 90 degrees, is made up of both 2x and 3x. So in other words, we can say 2x plus 3x is equal to 90 degrees. And then it's simple algebra. This works out to be 5x is equal to 90 degrees. And then when we work out x, we have 90 over 5, and that works out to be 18 degrees. And the reasoning behind this would be, as we mentioned before, that the angle between the diameter of a circle and a tangent is 90 degrees. So let's move on now to the second part of this part A. Actually, before we look at Y, which is the second part of this question, let's look at Z. If we look at this triangle here, Z forms one angle in this triangle and the other angle is 54 degrees. And then we know X now, so then this angle here is a combination of X plus 2X, not so? So let's just write that in. This angle here is equal to 3x degrees. And now we know X is equal to 18, so therefore that angle is 3x, which is equal to 3 by 18, which is equal to 54 degrees. So we know this angle here is equal to 54 degrees. So we could use another reasoning to get this angle Z at the top here, which is that all angles, I'm just going to put that we're trying to find C here now, all angles in a triangle must sum up to 180 degrees. So therefore that means that Z, which is this angle on top here, plus 54 degrees plus 54 degrees must be equal to 180 degrees. So all we need to do is make Z the subject of the formula here by saying Z is equal to 180 minus 54 plus 54 here, which would work out to be 108, and that gives me 72 degrees. So now we know Z is equal to 72 degrees. So I am just going to write that in. So this angle here is therefore equal to 72 degrees. So we have done angle X. Yes, we know that is 18 degrees. We have done angle C. We know that is 72 degrees. So let's now look at angle Y. We're trying to figure out this one, which is right here, right? So this is angle Y. What reasoning can we use to solve this problem? And the one we are going to be using is that angles in the same segment of a circle have the same are equal to each other. So what does that mean? The segment of a circle is formed by this particular chord here, which is a line that is drawn up from one end of the circle to the other end that's not passing through the diameter. Okay, it's what we're typically talking about. And if you were to draw a line from each side of this line, this side and this side, to touch a part of the circumference in each case, so you see we get this forms this angle y, and then if we were to draw another line to touch from each side to touch another point, so if we were to touch here, right, we get 2 points that we are forming from this angle, this line SP, this chord SP, and that gives me the angle y because they touch right here, and then they also meet at Q. So according to this rule, y must be equal to z. And what is z equal to? 72 degrees. So therefore, y is also equal to 72 degrees. So this has brought us to the end of part A. Let's move on now to part B of this question. So for part B of this question, I wrote down everything they're asking us to find here, which is we need to find the angle MLN, which is this first one here, which is MLN. This angle right here is what we're trying to find. So I'm just gonna put a question mark there. We also need to find side NR, the length of the side NR, and the bearing of town R from town L. So this is the diagram we are given, right, where you have a series of lines connecting these different towns indicated by L, M, N, and R, right? So you have some distances given and the angles between these given as well. So if you look at this diagram, we have two triangles. We have triangle 1 here, and then there's another triangle here. And none of these triangles are right angle triangles. So this immediately tells me that we are talking about one of two rules. We are talking about either the sine rule or the cosine rule, because these rules apply to triangles that are not right angle triangles, and they're used to find either an angle or a side depending on the exact situation. So let's take a look at the first one here, which is the sine rule. What does the sine rule say? It says A over sine A is equal to B over sine B. So what do I mean by A and sine A? All that means is that, let's say this side here is A. A is the length of a side, and then the angle opposite that side, which would be in this case here, MLN, which is exactly the angle that we are trying to find, is equal to another side. In this case, let's look at this other side of this triangle here. In this case, B would be, small b would be 12 kilometers, and sine B would be the angle opposite. The angle is all that we're referring to is always opposite to the side. Okay, so if this is side B here, small b, then this would be angle big B. Okay, so let's actually write this down. So let's just say A, we're going to call this side A. We're going to write the information we are given. We know that is 10 kilometers, right? Let's say this, we're going to call this side B, and side B is equal to 12 kilometers. Do we have, which angle do we have? We have the angle opposite to side B, because remember we call this one side B. So then sine of big B would be 88 degrees. So in this case here, big B is equal to 88 degrees. And what we are trying to find, what we're missing, this one would actually be A. Okay, so this would be B in our diagram, and this would be A. So what we are trying to find is A, because that's the same thing as our angle MLN. Okay, so then it's just a matter now of plug and play. So I know immediately that the sine rule is what I need to use to solve this equation, because I have three of the quantities, the terms in this equation. I have A, I have B, I have sine B, and but the only thing that I'm missing is sine A. So as long as you're missing only one term, there's only one unknown, then it's easy to figure out what that unknown is simply by rearranging the equation to make sine A in this case the subject of the formula. So let's do that. So let's plug in the information that we have. So we know we're going to call A 10 and sine A is going to be unknown. And remember again that sine A is what we're trying to find, angle MLN. I'm just calling it A because it's easier, which is equal to side B, which is the length of side B, which is 12 over sine of B, which we already know from up here is equal to 88 degrees. So all we need to do now is a little bit of cross multiplication, which is where we multiply both sides by the opposite denominator. So we have 10 multiplied by sine 88 is equal to 12 multiplied by sine A. So we want to make sine A, well actually A, but let's focus on sine A for now, the subject of the formula. So to do that, we're going to move everything that's not sine A, which in this case is 12, needs to go over there. So since we're multiplying by 12 on the right hand side, when we move it over to the left, we are going to be dividing by 12. Because you always do the opposite of what you were doing on the original side when you move it to the opposite side of the equation. So this is equal to sine A. But we actually need to find A and not sine A. So I'm just going to flip this around. Sine A is equal to 10 sine 88 over 22. So how do we find A? Well, all we need to do to find A is simply find the sine inverse of everything on the right hand side, or the sine inverse of both sides, which is, I'm just repeating it over here, and that works out to be 56.39 degrees. So now I have A, so I'm going to write it in 56.39 degrees. Okay, so we have completed part 1, which is to find angle LMN. So let's move on to the other part here, which is to find the length of NR. So I'm just going to do it on the right hand side here. I'm writing it again. This is what we're trying to do. So in this particular case, we have two sides of a triangle and the angle in the middle. This is a dead giveaway that we need to use the cosine rule. Why is that? Because this is what the cosine rule is. The cosine rule states that any side squared, the length of any side, is equal to the sum of the other two sides squared minus 2bc cosine of A. And remember here, cosine of A, of big A, would have to be opposite to whatever side we're using for little a. So we can use this equation if we have two sides of a triangle that is not a right angle triangle, right? So we have two sides here. We have 12 kilometers and 18 kilometers, and we have an angle that is in between them. And do we have an angle that's in between them? Yes, we do. So what we need to find then, we could call this side A, right? Just because it's easier than saying NR. So let's write down the information that we do have. So let's call B, and I'm going to say B is this one here, which is 12 kilometers. And I'm going to call C, the other side, the length of that is 18 kilometers. And then angle A, remember this would be angle A here because it's opposite to the side that we have called A, is equal to 25 degrees. So am I left with only one unknown here? Yes, I am. The unknown that I don't have is A squared, which is exactly what I'm trying to find, because I have B, I have C, and I have the angle A. So it's just a matter of plug and play. So let's get A squared. So this would be equal to 12 squared plus 18 squared minus 2 by 12 by 18 by cosine of our angle 25, right? And this simplifies, and then this would give you A squared. This would actually simplify to give you A A squared is equal to 76.48 kilometers. And of course, we need to find the square root of that. 76.48, and that is equal to 8.75 kilometers. So I am showing you every step here, but when you're actually working this out on your calculator, I would highly recommend so that you don't have premature rounding and get an answer that is less accurate, because every time you round, like I did with getting a squared here, my answer becomes less accurate. So I would highly recommend, if you're doing this, that you would enter the square root first of everything on this side here, and that's going to give you the most precise answer that I am then just rounding to 2 decimal places here. So I get A, or NR, so I'm going to write NR because that is what we were trying to find, which is the same thing as A, is equal to 8.75 kilometers. And we have solved the second thing that we were trying to solve, which was this one. Now let's move on to the other part. Alright, so for the final part of this question, we are going to be finding the bearing of town R, which is down here, from town L. What does that mean? Well, that means that if I were to draw a line due north from town L, what is the bearing to town R? Or in other words, how many degrees does it take to get from this vertical line north, drawn from town L, which is our starting point, to town R? So, well, that's simple enough because we have already found our missing angle here, which is 56.39 degrees. So it's just a matter of the bearing being equal to the sum of all of these angles, which is equal to 50 plus 56.39 plus this angle at the bottom here, which is 25, and that gives me a bearing of 131.39 degrees. So this brings us to the end of this question. I hope that this was helpful. Thank you for watching, and I hope to see you back here next week for our next episode of our Q&A.